Hi there, folks. Today we're looking at congruence in overlapping triangles. And really most of what we'll do today is simply review of what we've already done with triangles, but visualizing these things is going to be a little bit more difficult. Okay, so the figures themselves, the drawings that we see are a little bit more complicated and have a lot of different pieces that are kind of crisscrossing, and it kind of just makes it visually a little bit more difficult to deal with. Okay. Everything that we'll do with this will be the same as what we've done with other triangles in terms of showing that they're congruent. So overlapping triangles are triangles that share a side or an angle. And notice that it's share a side or an angle. So when we talk about the common parts, we're talking about parts in terms of like CPCTC, you know what I mean? The corresponding parts of the triangles would be like the sides and the angles, all right? If it's not a common side, if it's not a side that they share, then it wouldn't be considered a common part. Okay, if it's not an angle that they share, it wouldn't be considered a common part. Okay, so for example, if I look at this particular figure right here, these are overlapping triangles. Triangles, they're kind of on top of each other. They're overlapping. If I were to kind of trace out these two triangles, it was triangle ACD, and notice there's more triangles than just ACD listed here. There's also, you know, AB, whatever that intersection point happens to be. And then ED with that intersection point. So there's lots of triangles going on here, but we're looking at ACD right now. So triangle ACD is this one right here. And then also triangle ECB. So ECB is this triangle right here. And so as I look at those two triangles and I want to see which pieces they have in common, again, it has to be a shared side or a shared angle. Well, right away, there's a shared angle that hopefully we can see. It's angle C down at there at the bottom. Angle C is one of the angles for the first triangle. It's also one of the angles for the second triangle. All right. The temptation for students here is to say something like segment BC or segment DC. All right. And while segment BC does overlap with part of AC, segment DC overlaps with part of segment EC. Those aren't common parts because it's not one that they share. See, BC is a side of one triangle, but it's not one of the sides of the other triangle. And even though there's some overlap there with part of one of the other sides, we wouldn't consider it a common part, okay? Yes, it's an overlapping piece, all right, but it's not a common part, okay? If I look at this one, same kind of thing here. If I were to kind of trace these out, I want ABD, so ABD is this triangle right here. And then triangle DCA. So DCA is this triangle right here. I want to talk about the thing that they have in common, the common side or common angle, the one that they each share would be segment AD up there. So AD is the one they have in common because it's an entire side that both of them have. And again, you know, we might look at other pieces that we want to say are overlapping. This one doesn't really have any other overlapping pieces. You know, we might look at something like point E, all right? But again, we're only talking about angles and sides that they have in common, okay? So let's use this in the context of a proof. And really, again, these proofs are going to be the same as what we've been doing. The big difference is it's harder to look at. All right. And one of the recommendations I would make is to kind of separate these things. OK, after they're labeled or after we've, you know, kind of marked some of these pieces, maybe we want to separate these two things out. OK, might make it easier to see. So if I look at this one, let's start by marking it before I set up my statements and reasons. It says angle AEC. So AEC is this angle right here, is congruent to FCA. EAC, I read it incorrectly. EAC, is this angle right here, is congruent to FCA, which is this angle right here. All right. And then FAC, so FAC, which is this entire angle right here, is congruent to ECA, which is this entire angle right here. And see, right away, this looks messy, all right? I can't tell what's going on this thing because I have those bigger angles that are made up with the smaller angles, and all right, this is an example where watch what happens if we separate it. Watch, let me draw these separately. And when I draw them separately, I like to try to keep the same orientation for each. So here's AFC. I'm just kind of dragging them apart. Here's ACE. And so now when I label these things, let's start with EAC and FCA. Those are congruent. And then FAC, these guys, and then ECA, this guy. See, that makes a lot more sense. And so when you separate these out, it's really easy to see these a little bit clearer, okay? So break these things apart. Now, it's beneficial to have them overlapping sometimes and to kind of see the pieces that are overlapping. Like this one, we can see that this is an overlapping piece, AC down here, okay? And that's going to be a critical part of this proof, okay? So now let's set up our statements and reasons. And so as I look at this thing, once again, let me copy down the given. You can probably barely see that. Oh, that is an A. Trust me. Trust me, it's an A. Oh, man, I erased too much. There we go. So I start with what's given, and I already have that marked in terms of I separated out the triangles, and I marked those angles so I can see it in my drawing. All right, that's what's given. I want to prove that AF is congruent to CE, and so those are parts of these two triangles. So really all I need to do is prove that the two triangles are congruent. And so as I look at this thing, I have two angles. Well, so now I'm looking for maybe angle, angle, side, or maybe something like angle, side, angle. And so as I look at this thing, go back to that critical aspect of overlapping triangles have something in common. The thing that these have in common is AC, which means, hey, here's AC. Well, that's got to be congruent right here to AC. All right, so let's start with that next step. So AC is congruent to AC. All right, AC is congruent to itself. If I mark that over here, that's this guy being congruent to itself. We've used that before. That's our reflexive property. Okay, and since I've drawn these separately, we can kind of see how that matches up. Well, that's angle, side, angle right there. So now I can say that the two triangles are congruent. And again, be careful as you write these. So triangle AFC. So if I labeled that one as AFC, this one has to be C because that matches with A. EA is kind of how those match up. And students get thrown off by that a little bit because they're like, well, shouldn't A be in the same position? But keep in mind, A in one triangle is a completely different angle than A in the other triangle, okay? Because remember, that point had multiple angles at it when we had these things combined. So keep that in mind. And once again, I can say that these are congruent because of angle, side, angle. And now that I have the two triangles congruent, it means their parts have to be congruent. So for this one, AF has to be congruent to CE, and that's because of CPCTC. And so this is not a difficult proof, but it's difficult to visualize when we have those triangles drawn together. It's easier if we separate them out, okay? That's the big thing with overlapping triangles, is the visualization piece, and that's really hard to teach. All right. And sometimes it's just hard to see because there's so much going on. If we split it up, it's a little bit easier to see. Okay. If I look at this next one, so this guy, I've got CA is congruent to CE, BA is congruent to DE, and I want to prove that BF is congruent to DF. Okay. And so I look at what was given here, CA, which is this entire side. And that's kind of hard to mark. Maybe we can try to straddle that line or something like that, and then congruent to this guy over here, and maybe we try the same thing, all right? It's not easy to mark when it's written in this format because of the overlapping triangles, okay? And we have quite a few triangles here. Like when you look at something like, this guy, there's a triangle here that overlaps with this triangle here, okay? And so those would be triangles that maybe we want to look at. All right. We also have like this bigger triangle. The entire thing is a triangle. All right. This really big triangle right here. So maybe we want to look at that separately. Okay. And we even have like these little triangles in here. So we've got this little triangle and this little triangle, okay? And those aren't overlapping, but they're part of this entire thing, okay? And so as we're starting to look at this thing, we have a lot of different little triangles to look at and big triangles to look at. It helps to start to separate these things out. And so if I think about that first piece of given, I'm going to draw this thing a bunch of times here as I kind of separate this thing. That first given talks about the sides of the really big triangle. So the first thing I would probably do is just draw the really big triangle. Say, hey, here's this really big triangle. It was CAE. Okay? And see, I can easily label what was given now with CA and CE being congruent. Okay? It also tells me that BA is congruent to DE. And so there's a couple triangles that use that. There's the set of larger triangles. So maybe I'll draw those first. Sorry, let me go a little bit bigger on that. Oh, kind of running out of space here. Let me go a little bit. Let me go down a little bit. Sorry. There we go. There's A, B, E. Okay, so I'm drawing that kind of medium-sized triangle right here. Okay, and then the triangle that it overlaps with, and so this is good to have because remember those overlapping triangles usually become crucial to this thing. So that's A, D, E. And then I also have those little triangles I was talking about. It might be beneficial to draw those as well. And these aren't necessarily overlapping. And so I've kind of drawn them together here. This is B, A, F, D, and E. Okay, so drawing those two little triangles, and I could separate those a little bit more if I wanted to, spread them apart, but they're not really overlapping. They're pretty easy to see. So now let's start to label these pieces. So B, A, and D, E, well, that occurs here. B, A, and D, E right here. We can also see those here in this set of triangles as well. Okay, and so really I've kind of listed my given, I've added my given to the picture here, to the drawing, but I've added it to all the separate pieces of the drawings. Okay, and so now let's jump up to my statements and reasons. Let's go down here for my proof. Okay, and notice I'm going to focus more on these separate drawings than I have than anything else. Okay, so let me start with what was given. It was CA was congruent to CE, and it was AB or BA congruent to DF. Okay, that was what was given. And I have that copied in all of these pictures. So now I want to start to move around this triangle and see what else I know. Okay, so maybe I'll start with that first piece of given. That first piece of given is listed right here by showing those two sides are congruent. Okay, and so really the first thing I should notice about that big triangle is that big triangle, that's an isosceles triangle, which means these base angles have to be congruent. Okay, and keep in mind right here they're listed as angle A and angle E. But remember from the original, angle A represents too many angles to call it angle A. That would be something like angle BAE for this one down here. Okay? And this one would be something like angle DEA. So just make sure you're going back to the original for those labeling purposes. It was that entire angle. So let me write that down here. Let me make that my second step. Okay, that's the first thing I noticed. BAE is congruent to angle DEA. And that's because the base angles in an isosceles triangle are congruent. Okay? But now the other thing I want to do here, since I've labeled those as being congruent, I want to label those congruent in any other triangles that I've drawn here. See, I separated this thing out so that I could see everything really clearly. Well, BAE exists right here in this triangle as well. Okay? And right here, DEA exists in this triangle right here as well. So I want to make sure I label it in all the little pictures I have. Okay? And I think that's it. I think I got them all. And so as we start to look at these pictures as I kind of add things, the two medium-sized triangles right down here, we're getting closer to those two things being congruent. I have a side and an angle for each of those. So maybe there's something else I could say about these. And these, remember, were the overlapping triangles. Notice their bottom segment is AE for each. Well, doesn't AE have to be congruent to itself? Thinking about the larger triangle up here. Oh, I should use 3 dashes. Okay. And so for this one, that's going to be my next step. I'm going to use those overlapping pieces. And again, you'll almost always use those overlapping pieces here because it's kind of the point of what we're doing right now. Okay? And it gives us a really easy way to say two things from two separate triangles are congruent because they share that thing. They have that thing in common. And that's my reflexive property. Okay? And notice, even before I wrote it down here, I labeled it in all of the pictures that I have. Oh, I missed this first one. Okay? AE is congruent to itself. Okay? And now if you look at those medium-sized triangles, the ones that were the overlapping triangles, I can say that those two triangles are congruent. So triangle ABE, so triangle ABE is congruent to triangle. Just be careful about the labeling here. It's EDA. Okay? Those are congruent because of side angle side. Okay? So now I have those two triangles congruent. That means all of their pieces are congruent. So I want to think about that for a second and how that kind of relates to some of these other guys, all right? And so as I'm looking at this thing, if their pieces are all the same, that means something like AD is congruent to BE. It also means that like angle E is what it's listed as right now, is congruent to angle A. All right, but again, those things are listed in a little bit of a strange way, all right? But if I kind of use that here, I could say, or like B and D congruent. So kind of start to think about that. And really, the last set of pictures that I have here was these guys. So I've already proven that the big triangle, I've already done everything I can with the big triangle, being that it's isosceles and which angles are congruent. I've proven that the overlapping triangles are congruent, so now I know all their pieces are congruent. But to get to DF and DE, that's part of this little set of triangles, okay? And so we want to ask ourselves, how do the pieces of these guys translate to these two triangles? Okay, and so I mentioned kind of the angles and the sides. You know, AD, well, that doesn't work with either of those little triangles. Okay, something like, the angle right here at B is the thing we're looking for. So this angle right here is the same as this angle. Okay, and this angle right here at D is the same as this angle right here. And so again, we're going back to the overlapping pieces here. And the overlapping pieces are those angles right there. So that was angle ABE, angle ABE, is congruent to angle EDA, and that's CPCTC. But as I start to label that in all of my drawings, sorry, I drew a bunch of little arrows here. Let me erase those. If I label those angles being congruent in all my drawings, that was this angle congruent to this angle. But now that translates over here to this angle right here and this angle right here. I could label them up here in this picture if I wanted to. Okay? And so as I'm looking at this thing, all right, I also have these guys if I go to the bigger picture. If I look at those two smaller triangles, I have an angle and a side. Man, all I need is another side or another angle, and hopefully you're looking at this going, wait, there's one that's obvious here, and it's these guys right here. These two angles have to be congruent because they're vertical angles, okay? So that's BFA and DFE. Make sure BFA and DFE, those are congruent, and that's because those are vertical angles. Okay? And now that I have that, if I look at those two little triangles have to be congruent. ABF me check my labeling here. So I did ABF, so EDF. And again, those are congruent because of angle, angle, side this time. Okay? And so now I've shown that these two small triangles are congruent, but that's not what I wanted. I wanted the pieces of those BF and DF. I wanted to show that this piece right here and this piece right here are congruent. Well, I can say that now because the triangles are congruent. Okay? That's my CPCTC step. Okay? So BF and DF. And again, that's CPCTC. Okay? And yeah, this was a pretty lengthy, involved proof, all right? But nothing in here is really difficult if we take it one step at a time and if we have those triangles separated, okay? The thing that makes it tough is trying to see all of that in the confines of this picture up here, okay? It's almost impossible to keep everything straight when all that stuff is on top of each other. But notice a couple key elements here. We split everything up so that we can see everything easier. Okay, but then the critical aspects of connecting these things come down to the overlapping pieces. It came down to side AE being overlapping between the medium-sized triangles. Okay, it came down to the medium-sized triangle and the small triangle having an angle in common. Okay, and so those overlapping pieces become a critical aspect of this thing when we're trying to kind of label the different pieces in these smaller pictures. Okay.